Hey, welcome to your practice test. I hope you've done a bit of revision. Not much sense in wasting a test if you haven't prepared for it. So let's go through what we're going to do here. This is on circular functions, and the total marks over here are out of 40. Okay, so that means probably you'll need about 1.2 minutes a mark, so you're going to take about 45 to 50 minutes to do this test. That would be good if you could do it in that time. Okay, what I'm going to do is show you a question. Here's question 1 for a start. And then I want you to pause the presentation and have a go, and then scroll down to the next question and so on. And then watch it at the end, pause it, and when you're finished and you're ready to submit your work, roll the video and I'll go back to the beginning and actually go through all the questions. You can see me do them, and then you can mark your work as I show you. All right, let's come down now and have a look at question 1. Here we go. Pause the presentation and have a go. Let's go now to question 2. Okay, you can see down the bottom right-hand corner approximately the marks allocated for each one, and also looking down here whether they are level A, B or C in difficulty. Right, pause it, have a go. Let's go down to question 3. Okay, pause it. I'm going on to question 4. We are in question 4. And on to question 5, part A, and part B, and then question 6, and I think question 7 is the last one. 7 part A and 7 part B, 7 part C now, and I think that's all I've got for you. Yep, so how did you go? Watch me now. I'm going to go back and work them out for you and show you the marks then. Okay, so stay with me now. We'll just scroll back here and go to question 1. Here we are. Let's do it now. Okay, cos theta plus pi on 3. First of all, the formula is cos theta cos pi on 3. Take sine theta sine pi on 3. That's important to know the formula for that one. So that's equal to the cos of theta times a half. The cos of pi on 3 is a half minus the sine of theta. Sine of pi on 3 is root 3 on 2. So technically, look up the top here, because I've said that, we should write this answer as neg root 3 on 2 sine theta plus a half cos theta. Okay, like that. Okay, let's mark it now. It's only worth 3. 1 for the first line and 1 for each of these two values. I'll forgive you if you didn't put it sine theta term first this time. Okay, let's look at the second one now. So the ticks here indicate a mark. So here we are, sine 4 pi on 3, cos theta, take cos 4 pi on 3, sine theta. Now let's put in the numbers. So 4 pi on 3 is an angle in the third quadrant, so its sine is going to be negative. That's going to be minus the sine of the working angle, pi on 3, cos theta. Now the cos of 4 pi on 3 is also going to be negative, so it's minus the cos of the working angle, sine theta. Okay. Let's work out these values now. Minus the sine of pi on 3 is minus root 3 on 2 cos theta. And a negative times a negative is a positive. Cos pi on 3 as a half. Okay, so it's plus a half sine theta. And you really should have that sine theta term in the front, because of the question said what form of the answer it should be in. I won't penalise you for that at this stage. Okay, 1 mark there, 1 mark, and that's a bit of a tricky line, and one mark there. If you got to that line, then you can have all 3 marks. Okay, you don't necessarily have to put in that line there. Okay, were you able to get a few marks there? I hope you were. Okay, let's move on now. Mark your work out of 6 down here. And this standard of question is about the usual C standard. Let's move down now to question 2. Don't know how you went with question 2. I've got an arrow here already to indicate that these are C marks. So you should be able to do this from basic considerations. Okay, first of all, we want sine 2a. Let's write down the formula. 2 sine A cos A. Very helpful if you know your formulas. Okay, now let's put the numbers in. So it's 2 by 5 on 13 by 12 on 13, which is 120 on 169. Okay, 1 for the formula and 1 for substituting in. We don't need this line perhaps here. It's just a simple problem here. What about cos 2a? I've chosen cos squared A take sine squared A. I'm going to do that, but you could have used 2 cos squared A take 1 or 1 take 2 sine squared A. They are also equivalent formulae for cos 2a. So cos squared is 12 over 13 squared, take 5 over 13 squared, which if you do that is 119 over 169. So basically we want for you to choose a formula. You could have used these as well, or instead rather, and then the numbers in. So just there. We won't worry about actually simplifying it. Okay, so there's 4 marks there. A tick is a mark here. All right, let's go down and look at question 3. We're given that A is an acute angle, B is an obtuse angle, where we're given the cos and the sine. Find the exact value of cos A plus B. Well, I think you probably know with the expansion of cos A plus B, you need the cos and the sine of both the angles. So let's go searching them out now. Cos of A is 5 on 13. Probably what we'll do is use sine squared plus cos squared, squaring it as we go, equals 1. Okay, so sine squared A is 1 take 25, 144 on 169, subtracting 25 over 169 from both sides. So therefore, sine of A is plus or minus 12 on 13, taking the square root of top and bottom there. Okay, I'm going to come back here. Okay, we'll just move this around a bit. There we are. Okay, so then we know, however, that A is acute, less than 90, so it's a positive value. Sine of A is 12 on 13, not negative 12. So we've now got the cos and the sine. Oh, I shouldn't tick that because I'm not going to put a mark there. We've got the cos and the sine of A. We're going to need the cos and the sine of B, so let's try and do that now. Do the same way. So the sine of B is 3/5. So we could say 3/5 squared, which is 9 on 25, plus cos squared B is 1, because sine squared plus cos squared of any angle is 1. So therefore cos squared B is 1 take 9 on 25 is 16 on 25. Thinking of 1 as 25 on 25. So therefore the cos of B is plus or minus 4/5. Okay, but B this time is obtuse. So its cosine is going to be what? Neg 4/5. Because it's in, well, could be in the second quadrant. Okay, well, it could be bigger than that, but in either of those two quadrants, then we are going to have a negative cos. So let's go and do the final answer now. I have to go over here, I'm running out of space. the cos of A plus B is cos minus sin. Do you remember that? Okay, so we need to put that down. And so it's the cos of A we had before, 5 on 13, times the cos of B is neg 4/5 minus sine of A, 12 on 13, by the sine of B was 3 on 5. So working all that out, we've got neg 20 on 65, take 36 on 65, which is neg 56 on 65. Okay. Right, we'll just leave it there. We're not worried about changing that to a decimal at this stage. So we've got 5 marks there. So we're only going to give one, because this is a fairly basic procedure, 1 for that and 1 for that only. Okay. Then for correct substitution here and here, nothing for the formula, but if you got to that line, you've got 4 marks. Okay, and then 1 for the answer this time. Oops, oh, look at that, left out the negative. Neg 56 on 65. So, it's out of 5 there. So if you were able to get down to here, you should have shown some working, but if you got to there, you would get 5 for that. But ideally, show some working. And if you didn't get the whole way down, go back and see how many part marks you've gotten there. All right, mark it out of 5. How are you going? I hope you're scoring a few marks here. Right, let's go up to question 4 now. Okay, so question 4 is a pretty challenging one. I've made this an A-type mark. Don't know whether that's exactly an A-type question, but let's have a look. Now, a problem here is we're given cos x, and we want the sine of a half x. Now, you've got to be a little bit flexible here. You know that the cos of 2a is 1 take 2 sine squared a. Therefore, if I put in here cos of x, this formula becomes 1 take 2 sine squared. What's the connection between this and this? This angle is half of this one, isn't it? So that's how you get to x on 2. So I guess you might have had a lot of trouble with this. This is the crucial line here now, to see that this is the double angle or duplication formula. Now you can stick the numbers in. Cos of x is neg 3/4 equals 1 take 2 sine squared x on 2. So what that means is we can now simplify this. Okay, so implied sign leading on your argument in an equation. Subtract 1 from both sides. Be neg 7/4 equals neg 2 sine squared x over 2. Okay, and therefore, if we divide both sides by 2, we get 7/8 equals sine squared x over 2. Now, taking the root of both sides, we'll just leave it as plus or minus root 7/8 is the sine of x over 2. Okay, now, let's have a look. What is it, positive or negative? We've got to go back up the top here. X is between pi and 3 pi on 2. So what's a half x? It's between pi on 2 and 3 pi on 4. Okay, so that makes it in the second quadrant. So you must make the statement sine of x over 2 is greater than 0. In the second quadrant, the angle has a positive sign. So therefore the final answer, sine of x over 2 equals root 7/8. You could change that to root 7/2 root 2. We'll just leave it like this for the moment. So there are some things that must be there. Well, first of all, let's tick this first one. Did you get the connection between x on 2 and x? X is the double of x on 2, so you can use that formula. Then you had to get, your next one is down here. And you needed to have some reason for making the sign positive. So you had to say this here, Okay, and this one up here, or this one. Okay, you've got to have some reason for choosing the positive. So you should have this line as well. Should have plus or minus there, not just a positive by default. A lot of people would do that by default. So here we've got one up the top, one to get to here, one to get to plus or minus, one to decide what the answer is, and one to state the answer. Okay. You must have some reasoning here, because it's important that you realise an equation like this, a squared equation in sine, has plus or minus values. All right, can you total your marks there? So there's a few little tidbits in there that people could miss. All right, let's come on down now and have a look at question 5. Hope you're scoring some marks there. Okay, so in question 5, it's back, look down here, it's back to a C-type question. You're expected to do this fairly easily. So let's rearrange this. This first equation implies that sine x equals a half. The general procedure is to work out a working angle. So the working angle is pi on 6. Then we'll work out what quadrant it's in. Okay, so here it's a half, so it could be in this quadrant or this one with a working angle there of pi on 6. And therefore the solution is x equals pi on 6, or around here 5 pi on 6 plus or minus k times 2 pi. Therefore let's list all the possible angles. Let's look at the domain. It's from neg 2 pi to 2 pi. So let's go around positively for a start. We've done that. Pi on 6 and 5 pi on 6 for these two positions. Now what are they coming around negatively? Well, what would you say now? So it's neg 7 pi on 6 to get to this one negatively, and this one negatively is neg 11 pi on 6. Now usually we would write them as the negatives first and the positives second, but that will do at this stage here. So let's have a look at the marks for that. We've got 4 marks, so that's pretty generous. You had to find that the working angle was pi on 6, and then to find equivalent positions. So let's just rub this out. That's not actually a mark there. Either of these two steps is a mark. And then for listing these two is 1 mark, and these two is another mark, giving you 4. Okay. You must see in the middle here for 1 mark, one way or another, that you have those two angles. All right, total it up. Hope you're going well. Let's come down and have a look at the next one. So rearranging this to get a single function in sine, cos or tan. The first line would be sine 2x would equal root 3 over 2. Okay. What's the working angle? An angle whose sine is root 3 over 2 is pi on 3. Okay. So therefore, determining the number of solutions you've got here, you've got pi on 3 here. That's x and y, I should label those. And then where else is it positive? In the second quadrant, coming back, so it's 2 pi on 3. So what have we got? We've got 2x is, on one revolution, pi on 3, or 2 pi on 3, plus or minus k times 2 pi. Look at the domain. You're allowed to go for x from 0 to 3 pi. That implies that 2x would go from 0 to 6 pi. So we can do 3 revolutions. Let's do that now. So 2x is pi on 3, 2 pi on 3 on the first revolution. Add 2 pi, which is 6 pi on 3, so they become 7 pi on 3 and 8 pi on 3. And we're allowed to go around again for 2x. So adding 6 pi on 3 again. Sorry about that. we've got 13 pi on 3 and 14 pi on 3. All right, so those are our angles for 2x, and then dividing both sides by 2, pi on 6, 2 pi on 6, or pi on 3, 7 pi on 6, and here now 4 pi on 3. Oops, I put 7 pi on 3. Okay, it didn't cancel there. That's 7 pi on 6. 13 pi on 6, dividing this one by 2, 7 pi on 3. Really cancelling out the ones here that are divisible by 2. All right, oh, I shouldn't tick it, should I? I've done it incorrectly again. There's not a mark for all that. Okay, so we'll get rid of these marks down here. All right, let's mark it now. So there's one mark again for finding the correct working angle. There's one mark now for either indicating that or this line where you've got two angles given there. And I've given a mark up here, sorry. I've given a mark for that. Well, that's a bit of a generous mark. And then there's only one mark for all the answers, so you've got to have all of them for one mark. I think this is a generous mark up here, but I'll give it to you for rearranging that. A bit of a generous mark, that one. Okay, what'd you get out of 4? Hope you're doing well here. Let's keep going. Question 6. Okay, so question 6, I put A marks. Not sure whether it's hard enough for A marks, but let's give them to you anyway. Okay, so tan squared theta plus 1 by 1 take sine squared simplifies to 1. Well, what can you do? You'll say this equals, now tan squared. Well, at this stage, we'll call that sine squared. There are some formulae for tan squared. We haven't done them yet. So the first step is, I think, to get rid of the tan and work all in sines and coses. You'll see why in a minute. Okay, so that's the first stage. And then you can say, well, let's get these two over a common denominator. Let's get them over cos squared. So this is already sine squared over cos squared, so it's sine squared plus, now what's 1? That's cos squared on cos squared. So let's put it all over a common denominator. And of course now you've got something here. Sine squared plus cos squared is 1. So 1 over cos squared by 1 take sine squared. And the reason for that simplification is since sine squared plus cos squared equals 1. Squared theta plus cos squared theta equals 1. Putting that in brackets. Because this is a show that, so it's dangerous, isn't it? You want to show all your working. So now we can do it again. 1 take sine squared is cos squared. For the same reason, since sine squared theta plus cos squared theta equals 1. And then we can cancel and it comes to 1 as required. Always good to put that in. It used to be, back in the old days, QED, quod erat demonstrandum, which was required to be shown. Then it went to RTP, required to be proven, and the modern way is as required. Okay, let's put in some marks here. So the first one is for this one here, to change tan theta to sine over cos and square it. Then the next one is to replace this sine squared plus cos squared with 1. Okay, and then the next one is to change 1 take sine squared, where's this one, to cos squared. Okay, and I've missed one out here. No, sorry, there's a 1 for that as well. So here, to get this common denominator is 1, that line. Then to change the top to 1 is another one. To change the 1 take sine squared is 1. And then to cancel it. Okay, there's actually no mark for the final line here because that was given to you. That's the problem with show that. You have to be careful. A lot of detail here needed so that people can't accuse you of looking at the answer and trying to fudge it backwards. Right, how did you go? Okay, just remember the sine squared over cos squared, then a common denominator, changing that to 1, changing that to 1, and cancelling. Okay. You must show most of those steps there because it's a show that. All right, let's go down now and have a look at 7a. Show that sine plus sine simplifies to that. All right, so there are a couple of ways of doing this, but I don't know what the easiest way is. I think it's easier to use sums to products, because can you see you're wanting to end up with a product here from the sum of two functions? So let's use the sum to products formula. So what's that say? Sine plus sine is 2 times sine of half the sum. So you have to put this out carefully so people can see what you're doing. Half the sum, cos of half the difference, so it's that one minus that one. 2. Now just watch this now. What am I saying here? I'm trying to apply the sums to products formula to a complicated expression. So I'm having what I call a generic approach. That is, think of it in words. Right, let's do it again. So sine plus sine is 2 sine half the sum of the angles, cos of half the difference, because these angles are complicated looking here. So 2 sine of. Now what have we got? What does this become? B's cancel. It's 2a on 2 cos here. Now what's this? A take A, but B take neg B is 2b on 2. Okay, so it's 2 sine A cos B as required. Okay, now I've only put 2 marks there, so what would it be? Well, I think we'll go 1 for that whole line, so that's complicated. You must show this because it's a show that. You can't just put the answer. Then you must put 2b on 2 and 2a on 2 because it's a show that. There's no mark for the as required line, as you know, because that was given. Everybody's going to try and fudge it down to there. Okay, only 2 marks there. Possibly that they are better than the C's. Might actually be B marks there, I think. All right, come down to part B of that question now. And there's another one, isn't it? This is a bit repetitive, this one. Sine cos minus cos sine. Well, it's recognising a pattern, isn't it? Sine of an angle cos minus cos sine. Do you recognise that as the sine of the one angle plus the other, isn't it? Okay. So, it's minus. So this is the sine of the first angle minus the second. It's hard to show that here. And you could probably put it as supported, since sine, this is the formula, sine of A take B is sine A cos B take cos A sine B. That's what you've got, only you've got A plus B in there. Okay, so I think you need that in this show that. Okay, I think you need this reason, because otherwise you go straight to the bottom here and people would say that you fudged it. You must show that you're using this one. So there's 1 mark for putting that, I've got 3 marks here. I think that's a bit much for that. So let's change that. I think I did change that back to 2 marks. Yeah, that's why it came back to 40. So there's 1 mark for quoting the rule. You need to quote it here, I think. And then for showing how it's applied. So there's 2 marks there. Okay, let's go on to part C and see what we've got there. And I've got 4 marks here, and I think I've left that as 4 marks. All right, so the cos of 105 without using a calculator. So that's a hint. Can I get into cos of 105 without a calculator? Well, I could convert it to a pair of common angles, the values of which are known to me. So I could call that, and that's cos, take sine, isn't it? That's the way I remember it. In other words, cos of two angles added, you have the reversed sign in between there. A bit confusing. And then the cos of 60 is a half. The cos of 45 is root 2 on 2. Take the sine of 60, root 3 on 2, by the cos of 45, root 2 on 2. Notice that root 2 on 2 is equivalent to 1 on root 2. We don't usually use that because the simplest surd form, and that's a surd, isn't it, an expression involving the radical sign, we usually use the simplest surd form where this creates a integer denominator. So this is preferable there. I better not put ticks. We confuse it with marks. Okay, so let's have a look now. This becomes root 2 on 4, take root 6 on 4, and then you can put the answer. Don't jump straight to the answer because there's no marks for that. Okay, as required. You'll be accused of fudging it. So let's look at the marks now. So there's one mark for realising to break 60 and to break 105 into 60 and 45 and the formula there. Then there's one mark for the numbers here and one mark for that and nothing for the answer. So I actually did reduce this to 3, this one here, okay, 3 marks. All right, so I think that adds up to 40. Just check that. I hope you enjoy doing that as a bit of practice. So revise the things that you got wrong there. Study the rest of it. This did not cover all of the topics within this. So there are other things that you might study that didn't appear in this particular test. All right, good luck with the main one. Cheers for now.